All right, so I sent y'all 2 emails the other day. Email number 1 was just the information about the Rush program, reminding you that we have tutoring across the hall, but we also have the Rush stuff. For those of you who weren't here last time, they gave out applications for those that were interested. I do have one that I can make copies if anybody needs it, or I can go get some from down the hall. These are some of the criteria and where you can go to turn in the application. So that was the first email that I sent. The second email talked about the hours that tutoring is open over spring break. So they're not going to, or summer break, not spring break, summer break. They're not going to be open Thursday, Friday, and they're always closed on Saturday. So Sunday, Monday, Tuesday, Wednesday they're open, and then they'll be open again Sunday before classes start. The Sunday hours are normal hours, which is 2 to 6. We are giving our tutors a little bit of a break, and they're not going to be open all day. So Monday, Tuesday, they're going to be open in the afternoon hours. Wednesday, they're going to be open in the morning hours. And originally, the paper that I had posted in D2L said they were going to be open Friday, but the college has come back and told us that the college has to be closed on Friday as a holiday. So these are the most up-to-date hours. So 3 to 8:30 Monday, Tuesday, and 9:30 to 3 on Wednesday. And as usual, your tests have to be taken an hour before they close. So, we need to talk about when things need to be due. So, as far as, these are the dates that we have left to come to the class. That's it. We have no classes next week. I went ahead in purple, you can't really see down here, but in purple I wrote the days that the hub is open. So even though we do not have classes next week, the hub tutoring and testing are going to be open Sunday, Monday, Tuesday, Wednesday, and then again on Sunday. Okay? Next week we'll be off, but when we come back on the 8th, we're going to start with new material, Chapter 7. So, I am going, and here's what we have left for the rest of the semester. We are currently working on 5 and 6. So you have your homework that we're currently working on and the test that goes with that homework. And then we have homework for the next 2 chapters and a test that go with that. And then we have homework for the next 2 chapters, and remember there's no test with that. There's just going to be the final exam. And the final exam is going to be on all 10 chapters. Okay? And you'll have a review sheet for, you already have a review sheet for 5 and 6, you'll have a review sheet for 7 and 8, and then you'll have another review sheet for your final exam. We good? Okay? So after the current test, you'll have one more test and the final exam. So, we need to talk about your Chapter 5 and 6 homework and your Chapter 5 and 6 test. Now, I can go ahead and open your test today, which is 6/26 on a Wednesday, and it's going to close at hub closing on. So, if the test opens today, because I'm finishing material today, if anybody wants to take it today, you will have today, tomorrow, Friday. They're not open on Saturday. You'll have Sunday, Monday, Tuesday, Wednesday, Sunday. Oh, that's Saturday, Jim. That's not Sunday. I don't know what I was thinking. They're closed on Saturday. You'll have that day, and you'll have that day. Now, here's the question. Do you want me to close your test? This is your 5 and 6 test. Do you want me to close it on Monday, or do you want me to close it on Wednesday? I honestly don't care.
Wednesday.
Okay? Just know that if you wait until Wednesday the 10th, you will have 2 days of new material, and it will be 2 weeks since I last taught it. So just remember that, okay? So that is going to be July 10th, closing on Wednesday, 7/10. And I'll send this in an announcement as well. 7/10. All right, homework. Do you want your homework to close? First I was going to say Sunday, but if there's any of you like me that are going anywhere for vacation, I'm thinking either Monday or Tuesday.
Let's go with Tuesday.
I don't know why you have your own choice. All right, let's make it Tuesday the 9th. So homework is going to be due midnight on Tuesday, 7/9. So homework due at midnight. But that does not mean over spring break. I mean, a lot of y'all have been keeping up with your homework, but some of y'all waited until the last minute and you tried to cram your homework and you really didn't learn it and your test grade suffered. Some of y'all need to use this spring break week to make sure you know the homework so that you practice the homework so that you prepare for the test. Okay? Are we good with that?
I do have a question. Will the Rush Tutoring Center be open?
I don't think so. I think we are all off.
I'm just curious.
Let me see. I don't think they will be. Let me ask Maxwell.
Okay.
They quickly shook their head no. They do not work next week.
Okay.
So it'll just be the tutoring across the hall.
Okay. Which I haven't heard from that. So like as soon as I get an email like I'm good to go, there's not going to be any more follow-up.
No. And you may want to go touch base and see if they heard anything.
Okay.
Yeah. And see if they've heard anything. Yeah. So only the tutoring across the hall is going to be open. We good? Today we are finishing up 6.1 and doing 6.2, and then we're going to talk about the test a little bit. So 6.1, 6.2, talk about the test. 6.1, we started by talking about continuous and discrete, which we had talked about before, whether something was continuous or whether something was discrete. We also talked about probability distributions, and we said something's a probability distribution if all the probabilities add up to 1, and if your probabilities are between 0 and 1, okay? Now, we had just started this at the end of the class, but it was the very end of the class, so I wanted to go back over it. How to create a histogram in your calculator. You're going to put your data, the X, the first column of your frequency distribution is going to be, or your probability distribution is going to be an L1, and the second column is going to be an L2. We're going to go to second Y equals, which is your stat plot, and make sure that it's on. And we're going to check the histogram, because that's what we're trying to make. Our X is going to go into L1, our frequency is going to go into L2. Now, when we look at our window, we want our lowest X value, or L1 value, to be what the X min is. We want that highest value to be rounded up. So rounded up, that's going to be your X max. Your X scale is gonna be 1 because they want to count by ones. Your Y min is always gonna start at 0 because when you have that graph, your y-axis always starts at 0. So it's gonna go 0, 1, 2, 3, and it's gonna end at whatever that number is rounded up. So, for this problem, my X min would be 2, my X max would be 7, my Y min would be 0, my Y max would be 13. So for this particular problem, my X min would be 2, my X max would be 7, my Y min would be 0, and my Y max would be 13. My scale is always going to be 1 for these histograms because we want to count by 1. And we never touch our resolution. We always are going to hit graph for these because when you do Zoom 9, Zoom 9 tells the calculator, pick your own window. So we do not do Zoom 9 because that lets the calculator pick its own window. So even if you change the window to what you want, when you pick Zoom 9, it's going to pick its own window. It's going to say, oh, I want it to be this size. And it's going to take away your settings. So when you pick graph, it lets it use your window size. All right. Now, we started this problem last time. It says verify that it's a probability distribution. So we added up all of these numbers, and it equaled 1. And all of the probabilities are between 0 and 1. So we said because those two things are true, then yes, it's a probability distribution. Okay? Now, it says graph the probability distribution. Now, we did this last time, but I'm going to go back through it again. I still even have it up here. I went stat edit. I put my X as my L1, my L2 is my probability. So I did stat edit. Then I went to second stat plot, or second y equals, and I made sure that I had the histogram chosen, and I want it to be looking at L1 and L2. Some of y'all had it wrong because it said L1 and 1. You want it to be looking at list 1 as your X list, and list 2 is your frequency. Then I go to my window. I go to my window. My window starts at 0 because this is 0. This ended at 5, but I round it up and call it 6. So it goes from 0 to 6. Over here, I still start at 0. My biggest number is 0.575. I round that up to 0.6. Are we good? And then I hit the graph button. And this is what my probability distribution looks like. It said not only do I want to graph it, I want to describe it. So tell me what that probability distribution histogram looks like. It's skewed to the right. It is right skewed. So that's where we ended last time. So out here, I show you where I put it in stat edit. I show you the stat plot button. I show you the window button. I show you the graph button, and I show you that it's skewed to the right. Then I came down. This is why A was a probability distribution, because your probabilities are between 0 and 1. And the sum of your probabilities equal 1. So that's why it was a probability distribution. Then down here explains, enter your data in L1, L2, set the window, and then in your calculator you're going to hit the graph button, not the Zoom 9 button. Now, this is where we stopped. The next thing says compute and interpret the mean. Compute and interpret the mean. So we already have our data in L1 and L2. How are we going to compute the mean? Stat calc? Give it to me. Stat calc. One var stats, because we only have two to choose from. One var stats was our mean, our standard deviation, our median, our quartiles. Linear regression was our y equals ax plus b and our r value. So because I said I want the mean, so I'm going to do one var stats. Do I have to do anything else?
Yeah.
What do I have to do?
L1, comma L2.
I have to do L1, comma, L2, because I have two lists of data, so I want it to do the mean of both lists. So I'm going to pull that over just so that you can see that I'm doing the L1, L2 one var. So what do you think my mean is going to be? What is my mean going to be? This is going to be my mean. Now, what if I ask for the population standard deviation? What would my population standard deviation be? 0.739. They didn't ask for it, but I did. Cool? This is bringing up old school stuff. So down here I said to find the mean and standard deviation, run one var stats. Don't forget to do your L1, L2. All right, oh, there it was, compute the standard deviation. I am going to put that one down there and put that right there. So that is the symbol. This is my mean, and this is my standard deviation. What is the probability that a randomly selected individual 15 years or older was involved in 2 marriages? What is the probability that a randomly selected individual... Now, when we see probability, it automatically makes me think of what makes me happy over total. But this is a probability distribution, which means it's giving me the probabilities. Just like on the first test, y'all, when y'all were doing those graphs, and it either said frequency or it said relative frequency. If it said frequency, then you had to take that number and put it over the total. If it said relative frequency, then that was the percentage. Here, they're giving you the probability. So this is telling me that this is the probability. These are the probabilities. Now, if I had given you something like this, red, blue, green, pink, and I said, what is the probability of red? What would you have to say? What's the probability of red?
1/11.
Because this just says one person liked red, 3 people liked blue. So your probability is going to be the number of people over the total, what makes me happy over the total, because this is just frequency. Here, they've already calculated the probability. They've already done people over total. So this is the probability of a 0. This is the probability of a 1. So they've already done the relative frequency. So 15 years or older involved in 2 marriages. Let's go back to the top and remember, what does this chart show me? In the following probability distribution, the random variable X represents the number of marriages an individual aged 15 years or older has been involved in. What is the probability that a randomly selected 15 years or older was involved in 2 marriages?
0.121.
It is that easy. 2 marriages, there's the probability. It's not like this one where I gave you frequency. Here I gave you probability. So the answer to this one is 0.121. I didn't have to do it over total because I already gave you probability. I just had to read the chart. What is the probability that a randomly selected individual 15 years or older was involved in at least 2 marriages? If you are married at least 2 times, how many times are you married?
Is this as simple as that 1 minus?
You can. You tell me how you want me to do it. There's 2 ways to do it.
Saying at least 2, I think you'd add 2, 3, 4, and 5 together.
Okay, he's saying at least 2 means you could be married at least 2 means you can be married 2 times, 3 times, 4 times, or 5 times.
Yeah.
So that means 0.121, 0.027, 0.004, and 0.001. You can add all those together and you get 0.153. The other way, Rachel saw the word at least. And she said, oh, that's a 1 minus. So if it's at least 2, it's going to be 1 minus the less than 2. Because when we're doing 1 minus, it's the opposite.
Oh, okay.
So at least 2 is going to be 1 minus the rest of the story. So it's going to be 1 minus which numbers?
The 0.575 and 0.272.
And that's still going to give you the 0.153. So if you want to literally say how much does at least 2 marriages mean, that means 2 marriages or more. Or you can say, oh, Ms. Cooper said, anytime I hear at least is 1 minus, it's going to be 1 minus the others. And the others are going to be no marriages or 1 marriage. So it's going to be 1 minus the other 2. Cool? And then down here, I wrote it prettier. I just did that one. I didn't do the other one. But you can do it either way. It doesn't matter. They're going to give you the same answer. All right. They make this one look harder than it is. It says for problems 21 and 22, which we're doing 21, construct a discrete probability distribution for the random variable x. Then it says hint. P of x of I equals f of I divided by n. You're like, that ain't much of a hint. It's saying, what letter F, what do you think letter F means? Frequency. Take the frequency and divide it by n, which is the total number of people in your survey. We're going to do what we always do. 18 divided by whatever our total is. 18 divided by whatever our total is. 20 divided by whatever our total is. 35 divided by whatever our total is. If I total it up, it's 91. So 18 divided by 91, 18 divided by 91, 20 divided by 91, 33 divided by 91. That is part A. Part A. That is our frequency probability distribution. Now, I would probably go and do that in my calculator and write the decimal out, because our probability distribution needs to be decimals. So if I do 18 over 91, 20 over 91, 35 over 91. So it's going to be 0.198, 0.198, 0.220, and 0.385. Now, when I add these up, it may be 0.99 or 0.98 because I rounded, but it should be very close to 1. And all of these are between 0 and 1, so those are the two things that makes it a probability distribution. Just kind of like what we did when we did the relative frequency. All right, that's part A. Part B, draw a graph of the probability distribution. Okay, so when we draw our graph, where am I going to go first? Who? Stat edit. I've got to put in my data. So I'm going to go to stat edit. I'm going to clear out what I have in there right now. What goes in my L1 column? The games played, 4, 5, 6, and 7. What's going to go in my L2?
Your decimals.
Your decimals, 0.9, 0.198, 0.198, 0.220, 0.385.
Which those are, is that the relative frequency? Is that
Yes.
That's what I thought.
And it's really the probability distribution because we turned it into a decimal. So that's going to be my L1, L2. What do I do next? Second y equals. We're going to go in there and make sure that our histogram is chosen, make sure our stat plot is on, and make sure that we have L1 and L2 that we're looking at. Where are we going to go next?
Graph.
Ooh,
Window.
window. Okay. What should be my smallest minimum x value? 4. That's my smallest x. What is my biggest x?
8.
8, because you round that biggest one up. We always count by 1. Your y's start at 0. Now, what is my biggest y? This 0.385. We round it up, and what is it going to be? 0.4. Now, the good news is, on your test, everything is multiple choice. So you're going to be picking from answers. Now, we don't do Zoom 9, we do graph. So this would be what it looks like for my graph. So all of this would be my part B. Now let's see, draw the graph of the probability distribution. That's what they want. Now part C, compute and interpret the mean. And part D is compute the standard deviation. So where do I go to do the mean and the standard deviation? Stat,
Calc.
one of our stats, and what do I have to do?
L1, comma, L2.
L1, comma, L2. This is going to be my mean, which is part C. This is going to be my standard deviation, which is part D.
You won't let me type a comma in for one of our stats?
Is yours like this?
Yes, ma'am.
Okay, your L1 and then your L2.
Do I need to put something to the L2 frequency list?
Correct.
Okay.
Correct. So if yours is Like mine did it as one var stats L1 comma L2. That's one way your calculator will do it. The other way your calculator will do it is, it's gonna be like that. You'll have L1 there and you'll have L2 there.
My numbers are all different too.
Does anybody have different numbers than me?
I do.
I have 5.79 for the mean.
Is your 5 around the 8